All right, so moving forward, let's see, today's Tuesday. So we're going to go Tuesday through Thursday of this week. All right, we're going to be doing notes and practice. Most of you are going to Algebra 2 next year, and I spoke to some of the Algebra 2 teachers, and they asked me to cover factoring, review factoring here at the end of this year, because most students struggle with factoring in Algebra 2. So we're going to cover that. So Tuesday, Wednesday, Thursday, notes and practice problems. And then on Friday, we're going to do a study guide. Then next Monday, you're going to take a quiz, your last quiz in here. Well, your second to last quiz. On Monday, you're going to take a quiz in here. Then Monday is a modified exam schedule day. Or I'm sorry, Tuesday is a modified exam schedule day. Whichever day I have you as your scheduled exam day, whichever day is your exam day, you're going to work in the ALEKS app for the same amount of time as a class period. All right, I'm not going to ask you to work in there for 2 hours, but I'm going to ask you to work in there for a good 40 to 50 minutes. And then based on what you get done in that ALEKS app on your exam day will be your final quiz score. Yes.
You're grading it on how many topics you do?
Yeah, I'm going to grade it like I have been. So you go in there, you learn what I feel like is a respectable amount of topics, you're going to get a 10 out of 10. All right? So based on the fact that the factoring that we're going to be doing is review, all right, you should have an opportunity to do real well on this quiz Monday, and then you've definitely got an opportunity to do great on a quiz or get a great quiz score next week based on your ALEKS app performance and topics learned. Okay? So that's what we're doing in here for the rest of the year. So today, what we're going to do is we're going to talk about and we're going to review factoring. Now, today is just going to be notes, and then tomorrow and Thursday will be notes and practice, and then normal study guide on Friday. So today we're talking about factoring. Using a greatest common factor. All right, so what we're doing, factoring is the process of separating a polynomial back into a product. Polynomials that can't be factored called prime. All right, so you'll see instructions like factor the polynomial. By finding the GCF, greatest common factor. So example 1, we've got basically simple 3x plus 12. All right, when you're factoring polynomials, you always look at these terms. This 3x is a term, the 12 is a constant. You look at these terms and you ask yourself, is there anything that goes into 3 and 12 evenly? Or what is the greatest common factor of 3 and 12? All right, so if you pull out the 3, because 3 goes into 3 and 12, then we set parentheses. And then what you do is you take the greatest common factor and you divide it back into each term. So if we take 3x and we divide it by 3, we get x. If this symbol is plus, then this symbol is plus. And then we take the 12 and we divide it by the GCF. And when we take 12 and we divide it by 3, we get a 4. So 3 times x plus 4 is the factored form of 3x plus 12. And anytime you're factoring, when you're done and you've listed your factors, you should be able to just multiply. In this case, it would be the distributive property. 3 times x is 3x, and 3 times 4 is 12. So when you list your factors always need to multiply back to the original polynomial that you were factoring. So it's a simple way to check your answer every time you factor a polynomial. Just multiply the factors when you're done, and you should get the original polynomial. Let's take a look at something like 4y squared minus 24y. I'm going to ask myself, what's the greatest common factor of 4 and 24? All right, well, that's 4. And then the greatest common factor of y squared and y is just y. So our greatest common factor is 4y. So now I take each term and I divide it by 4y. So 4 goes into 4 one time, so we don't write it. And y goes into y squared y times. Because y times y is y squared. So if this symbol is minus, then this is minus. And then we're going to divide 24y by 4y. And 24 divided by 4 is 6. And y divided by y is 1, so we don't write it. So our factored form of this polynomial is 4y times y minus 6. And again, if we did the distributive property, 4y times y is 4y squared. 4y times 6 is 24y. Your factors should always multiply back to the polynomial that you factored in the beginning. All right, 15a squared b minus 30ab. All right, the greatest common factor of 15 and 30, well, that would be 15. It goes into both. The greatest common factor of a squared and a, well, that's just a. And then the greatest common factor of b is b. So 15ab is our greatest common factor. So then we take both of these terms and we divide them by 15ab. So I'm going to divide by 15ab and 15ab. So 15 divided by 15, that's 1. And a squared divided by a is just a. B divided by b is 1, and we don't write the 1. So if our symbol is minus, then we're minus. 30 divided by 15, well, that's 2. A divided by a is 1. We don't write it. And b divided by b is 1 as well. We don't write it. And we're done. All right, so 15ab times a minus 2. Now, when we're done with these notes, I'd like you to apply the distributive property here and verify this answer. All right, example 4. We've got 10x squared y squared minus 8xy. Greatest common factor of 10 and 8. Go with 2. Greatest common factor of x squared and x would be x. And the greatest common factor of y squared and y, that's y. So now we're going to take this GCF, divide it back into each term. So we're going to divide by 2xy, and we're going to divide by 2xy. So 10 divided by 2 is 5. X squared divided by x is x. Y squared divided by y is just y. We've got a minus sign here, so we go with a minus sign here. 8 divided by 2 is 4. Xy divided by xy is just 1, and we don't write the 1. So those are our factors. 2xy times 5xy minus 4. All right, we're going to factor 6y to the 4th. Plus 14y to the 3rd. Minus 10y squared. All right, so I'm looking at these values first. We got a 6, a 14, and a 10. The greatest common factor of 6, 14, and 10 is 2. Now, what we're looking for is the smallest exponent of y. Since we have a y in every term, we're just looking for the smallest exponent of y, and that's going to be y squared. So we're dividing each term by 2y squared. So 6 divided by 2 is 3. Y to the 4th divided by y squared. When you divide exponents, you subtract. Numerator minus denominator. So y to the 4th divided by y squared is y squared. Because 4 minus 2 is 2. We've got a plus symbol. Then we take 14 divided by 2, we get a 7. Y to the 3rd divided by y squared, well, 3 minus 2 is 1. So that's y to the 1st, but we don't write the 1. And since this is minus, our 10 divided by 2 is 5. Y squared divided by y squared is 1, and we don't write it. So 2y squared times 3y squared plus 7y minus 5 is the factored form of that original polynomial. All right, example 6, we got 18 x squared y z minus 24 x z squared plus 36y z to the third. All right, so now we're looking for the largest number that goes into 18, 24, and 36 evenly. 18, 24, and 36 evenly. And that's going to be a 6. Now, we've got an x squared, an x, but this third term doesn't have an x in it. And if the third term, if all the terms don't have an x, well, then we can't use an x as our greatest common factor. And if we look at the y's, we've got a y, then we've got no y, and we've got a y to the first. If all the terms don't have a y, then there can't be a y in our GCF. But we do have a z to the first, a z squared, and a z to the third. So our smallest exponent of z is just z to the first. So that is our greatest common factor. So now we're going to take each term and divide it by 6z. So 18 divided by 6 is 3. Now we've got an x squared divided by, there's no x to divide it by. So you're dividing it by 1. So x squared divided by 1 is x squared. Same with the y. We've got a y divided by 1, so which is y. And then our z divided by z is just a 1, and we don't write it. So since this is a minus sign, we take another minus sign. 24 divided by 6, that's 4. X divided by 1 is x. Z squared divided by z, that's a z. We're done with the middle term. Then we got a plus sign, so another plus sign. 36 divided by 6 is 6. We're dividing a y by a 1, which is just y. And our z to the third divided by z, that would be the exponent 3 minus the exponent 1, that would be z squared. So those are our factors of the original polynomial. All right, anybody have any questions? Okay, so what I would like you to do now is just go back to problem number 3. And for 3, 4, 5, and 6, just apply the distributive property to our factors and verify that that product is equal to the original polynomial that we started with. And that's all I've got for you for today.